So I'm going to do one more of these problems that has a linear factor and a quadratic factor, and then we're going to hand out something. We're going to work some things in class today. Okay. Shh. So this one is different than the one we did the other day because if you remember, there was just a linear term and a constant term in the numerator. Now there's a quadratic term. And what that does is it makes it harder to solve for coefficients A, B, and C. Okay, shh, time to quiet. But as far as the what we're going to do, I'm going to shrink this a little bit because I can't fit everything. So you have A divided by the linear term and bx plus c divided by the quadratic term. And again, the reason we don't factor this is you can't factor it with the real factors. So if we cross multiply the two terms on the right hand side, we'll have a times x squared plus 9 plus bx plus c times x plus 3. And that's all over x plus 3 times x squared plus 9. So by taking the two fractions and then combining them back together, I end up with the expression on the left-hand side having the same denominator as the expression on the right-hand side. So at that point, I can say to make these two rational expressions equal to each other, I have to make sure that the numerators are equal to each other. So what I have is 2x squared plus 4x minus 7 is equal to a x squared plus 9 plus bx plus c times x plus 3. So we multiply out the right-hand side. So we'll get a x squared plus 9a from here. And from the second product, we'll get b x squared plus 3bx plus cx plus 3c. So this times that is that, that times that is that, that times that is that, and that times that is that. Okay. And then you can group the terms according to the x squared one. So the two terms that have x squared are a and b. So we'll have x squared times a plus b, and then you have x times these two terms involve x, so you get 3b plus c, and then you have the two constant terms, which are 9a and 3c. So now by taking the coefficients on the left-hand side and the coefficients on the right-hand side for the x squared term, we'll get that 2 is equal to a plus b, and the x terms, that coefficient has to equal that coefficient. So there we have 4 is equal to 3b plus c, and then the constants, which we'll do in green, that has to equal that. So we get negative 7 equals 9a plus 3c. So same thing as the other day, and I'm going to ask you to do the next step. So what you'll do is you want to rewrite this in terms of one variable. So if you solve the first equation for a and substitute that in here, and solve the second equation for c and stick that in there, this third equation will become just a function of b, and then you solve for b algebraically. So solve the first equation for A. So A will equal be 2 minus B. The second equation, solve for C, 4 minus 3B. Plug those in. Third equation, do the algebra, figure out what B is, and then once you have B, you can go back and substitute that into the equation that you'll have here and the one that you'll have up there that you used for your initial substitution, and then you'll get you'll get A, B, and C. So I'm gonna let you do the algebra. Give you a couple minutes to get started. So it's only 2 months till we go to England. So it's starting to, now we got to start getting all the ducks in a row. So I bought a SIM card for my phone. So you got to use a phone over in Europe, you have to either buy an international plan for your regular carrier, but Verizon is very expensive. So the other option is you can buy a third-party card, which the one I got actually has a English number. So if I have people call me from England, they'll have a number that they're used to calling instead of having to call a U.S. number, which then gets transferred to. It's all crazy. It cost me $30 for 3,000 minutes or something crazy like that.
If someone calls you from here, is that a long distance call?
Yeah, that's the issue. So probably what I'll do is if somebody from here wants to get a hold of me, I'll have them send me a text message, and we'll do FaceTime or something like that. Because you can do FaceTime on your data. It's just a phone thing. But if there was the option of having a U.S. number or an English number. And if I had a U.S. number, then it was a problem. I figured more people will want to call me in England than from in America. So that's kind of the way you handle it. So I'm going to use my old iPhone for my England number, and then I'll have my regular phone for my other stuff. So. So check to see if you got the same result I did. So you solve the first equation for A. So A is 2 minus B. Solve the second equation for C. It's 4 minus 3B. And then you plug those into the third equation. So you get negative 7 times 9 times A, which is 2 minus B, plus 3 times C, which is 4 minus 3B. So that's what you should have gotten. Does anybody know what the minimum age of renting a car in the United States is? 25. Yeah, it's 25, which is kind of strange. It's also, if you want to rent a car in Europe, you got to also be 25, which means that you're very restricted on how to get around. There's also a maximum age, 70, I think. Some companies won't rent anybody over 70, which is not that far away from me now. It's about as close, well, I guess you're closer to 25 than I am to 70, but so when you go on job interviews, that's the biggest issue, is if you fly out to California and you have a company that's 2 hours away from the airport, you can't rent a car. So how do you get there? Well, they're kind of the companies sometimes are used to it. They'll hire a driver to come pick you up from the airport, and they'll take you to the hotel and that kind of stuff. Anybody get that? Anybody get my answer? B, 37/18. Okay. So you take that back now here and you plug that into here, 37/18. And that's equal, 37/18 is equal to, times 3 is equal to 37/6. So you've got 6 times 4, which is 24. 24 minus 37 is negative 13. So you get negative 13/6 for C, hopefully. And the first one, A, oops, why did it keep doing that? A is equal to 2 minus B, which is 37/6. So 12, 6 times 12, 6 times 2 is 12. 12 minus 37 is negative 25. So you get negative 25/6. Hopefully you got that answer too. Everybody get that answer too? Hopefully? Yeah? Okay. So what that means now is that the original thing that I was integrating, so if I wanted to integrate this now, let's see what I'd end up doing. So the integral of this is the same as the integral of these two things. So what I would end up doing is, let me get my numbers now. So A is negative 25/6. So I'd have negative 25/6 times the integral of 1 over x plus 3 dx. Then I'd have B, which is 37/18 plus 37/18 times the integral of x divided by x squared plus, x squared plus 9 dx. And the third one would be C, which would be negative 13/6 times the integral of 1 over x squared plus 9 dx. So what I've done is I've just gone ahead and broken up that second integral into the two parts, one that involves the x and one that involves the constant. So you take the constant a and you stick it out in front of the integral involving 1 over x plus 3. You take b and stick that out in front of the integral of x over x squared plus 9. And you take c and put that outside the integral 1 over x squared plus 9. And remember, this one is the natural log of the absolute value of x plus 3. This one would involve the natural log of x squared plus 9 because you'd use u substitution just like we did. And this one would involve the arctangent of x over 3. So they all have the same kind of result. So the final answer here, this is using what we did the other day. So the answer would be negative 25/6, the natural log of the absolute value of x plus 3, plus 37/36, the natural log of the absolute value of x squared plus 9, and minus 13/6 times 1 over 3 times the arctangent of x over 3 plus c. So you're saying, where did you get 36 from? Well, because when we used u substitution the other day, dx would be 2x dx. So dx would be du over 2, or x dx would be du over 2. So that's where the extra 2 comes from. And here, this comes from the fact that the integral of 1 over u squared plus a squared is 1 over a plus the arctangent of u over a. Okay, so let me hand out some stuff here. We're going to go back and do the easy one first, which is the separate distinct linear factors. So we got 6 problems to do. They get more complicated. If if you look at the last one, you'll be like, my God, that's what, yeah, that's right. But we'll do it. We'll do it. That's the impressive thing, is that we can actually do this stuff. It's not as daunting as it may initially appear. There's nothing that hard in the book. So, but it's not something that's outside of your capabilities. So the first problem is distinct linear factors. So factor the denominator, and then have a over one factor plus b over the other factor. Combine the two together, set the numerators equal to each other, and solve for a and b. And remember, go back to your notes. When you have distinct linear factors, you'll let x equal the two values of the to make the terms in the parentheses go to 0. So this is one we're doing first. The integral of 3 over x squared plus 9. So what I would do is do the partial fraction first, and then plug that back in and do the integral. So what you need to do first is take this and first factor the denominator, which I'm going to let you do. And then you'll have a over one of the factors plus b over the other factor, whatever that other factor is. So it's going to be x plus or minus something times x plus or minus something. So what I would do is I would write the factored form of the denominator here in terms of the rational expression. If anybody doesn't know how to factor that, just let me know. You should be able to just do it by observation.
So is it,
Yeah, what two numbers multiplied together give you 4, and if one subtracted from the other gives you 3.
Did you tell me that? It's disgusting.
So once you factor it, then cross multiply the numerator that's in the denominators, and then set x equal to whatever the two factors are, or the two solutions to the factors. Let's make sure everybody's factored it correctly here. Then I'll let you know what it is.
yeah.
Yep. Don't want anybody just hanging back saying he's going to do it anyway, so I'm not going to. Okay, looks like everybody's done it correctly, or at least tried. And again, it doesn't matter which one you have first. So if you have x minus 1 under A and x plus 4 under B, that's still fine. It's just your B's and A's will change place. Okay. So now you're going to cross multiply these two things. Come up with combine these two fractions into a single fraction back with the same denominator. Then you'll set 3 equal to whatever the numerator is as a result of doing that. So you've already solved it. Okay. You guys are moving along. Okay. So here's your expression, and we're going to let x equal -1 and x equal 4. That makes this go to 0 and this go to 0. So you end up with A is -3/5, B is +3/5. Now the question is, do you always end up with these being the opposite sign, the same thing but the opposite signs? And the answer is, I think if you only have a constant in the numerator, yeah, I think you do. Okay, so what that means is my original integral can be rewritten as the easiest way to do it is just take each constant, -3/5 times the integral of 1 over x plus 4 dx. So this is a. So the coefficient a just put outside of the integral, and then put 1 over x plus 4 there. And then the second one is b times the integral of 1 over x minus 1 dx. So that's what I'm solving now, not this, but that. And you can see that the answer is -3/5, the natural log of the absolute value of x plus 4, plus 3/5, the natural log of the absolute value of x minus 1. By the way, I found that you guys didn't catch me making an error the other day, or at least you didn't tell me. I'm going to go back and show you from yesterday or Tuesday's notes. Since the recording did not work, I went back and recorded it. And when I was recording it, I noticed I made a mistake. So let me do that while I'm thinking about it. Almost forgot to tell you. It was just a sign error. I'm not even sure I know where it is exactly. Let me see if I can. Does anybody remember? Did anybody not say anything because they? Pardon me? Oh, did we? Oh, did I? Oh, right here?
It's when you solved for A.
Oh, when I solve for A? Oh, I'm going too far here. Where did I put that? I gotta figure out where I solve for A. Where it happened to it? Oh, it must be here. Okay, which one did I make a mistake on? Right here? Oh, okay. 12 minus 37. Oh, this should be 37 over 18. Oh, you're right. Thank you. Yeah, I think I put 6 because I was thinking of what that simplified down to. Okay, so let's fix that. So you should tell me when I make a mistake. So that's 36 minus 37, so that's 1/18th. Okay, so we'll go back, and so that was 1/18th, and therefore this should be 1/18th. And this should be 1/18th. Anyway, I can't remember what. Okay, thanks for letting me know about that. Okay, so let's go to the next problem. Yeah, I can't remember now which. There was a mistake, so if you see me make a mistake, let me know. Okay, so the next one is a similar kind of thing, except if you factor the denominator, you'll have repeat linear factors. So this is the second case. So if you factor the denominator, you'll get x plus 2 times x plus 2. And that means you need to use the repeat linear factors form. So let me add a page here. So we have 7x plus 3 divided by x plus 2 quantity squared. So now that I've factored the denominator, remember, so what we're going to do is we're going to use partial fractions to rewrite this, and you have a over x plus 2 plus b over x plus 2 quantity squared. So now the rest of it's the same. The only difference is when you get to setting x equal to some value, to simplify the calculation, you'll set x equal to -2 because that'll make that term go to 0. The factor x plus 2 will go to 0. And we choose x equals 0 as the second choice, and you'll have to use your calculation of b probably to then calculate a. So just go through it and see if you can figure out once you get to it, but look back at your notes. So you don't cross multiply here because you've already got x plus 2 in the denominator of the second term. So that's, you don't have to multiply the numerator by anything. But you're going to have to multiply the first fraction by x plus 2 divided by x plus 2. The other difference is when you integrate the second part, it's not going to be the natural log because you don't have just x plus 2, you have x plus 2 squared. So you'll need to use u substitution on the second integral when you integrate, once you've come up with the coefficient and you want to integrate it. Okay. So remember, you let x equal -2 solve for b, and then you let x equal 0 solve for a. using B from your first part. So actually, I was just reading about rental cars. Make sure I'm giving the updated information. It says there are okay. In the past, if you were under age 25 and you needed to rent a car, you were out of luck because younger drivers tend to be more inexperienced. Rental car companies often were reluctant to rent to them. Even now, most rental car companies rent to younger drivers only with the addition of a hefty daily fee. In some cases, the fees can almost double the overall cost of the car. However, if you have available cash, the process for renting is the same as for any age group. Except typically the rental car company puts a hold on your credit card for the amount that the car is worth. So I don't know whether you'd have to give them, $10,000 in cash to guarantee your car. So I'm not sure. There's another interesting thing about rental cars. In the U.S., usually your personal insurance will cover damage on the rental car. But in other countries, that's not the case. So the cost of the insurance can sometimes be the same as the cost of the car rental. But it turns out if you have a Visa card, and I don't know if it's a particular Visa card, if you rent the car entirely with your Visa card, they will cover the car rental insurance, which is a huge deal. So I'm renting a car for 2 weeks, 3 weeks and a couple of days, and I think the cost is about $400, which is really not bad when you're considering it's 20 some days, like $20 a day for rental. And if I had bought what's called collision insurance, it would probably be $800. But by using my credit card, I save $400 in rental. And it does work because I actually did scratch my car up one time. Out of the many times that I've rented a car in England, I scratched it, this little tiny scratch. But it was a pain in the neck to get it all straightened out, but they did pay for it, so I know it does work. The interesting thing is in Ireland, they won't do that. There are certain countries that they won't, the credit card companies won't cover the insurance. And one of those is Ireland, which you think, what's the difference between England and Ireland? They all have, they look the same. They speak English sort of the same. And it turns out that because most of Ireland is narrow, rural roads, that's where people tend to have accidents. the funny thing is that that's what I drive on in England. So that for me, it's just as dangerous to drive in England as it is in Ireland. But for most other people, they usually keep to metropolitan areas, so they're not in a risky environment. Okay, so here we are. Let's solve this thing. So if we set x equal to -2, we get 7 times -2 plus 3 is equal to a times -2 plus 2 plus b. So that goes to 0. So you get b is equal to -11, -14 plus 3. And then to solve for a, you can plug x equals 0 in. So you'll get a times 0 plus 2 plus b, which is -11. So that's 0. So we get 3 is equal to 2a minus 11. So add 11 to both sides, you get 14 is equal to 2a, or a is equal to 7. Did I get that right, Daniel? he's my checker. Hopefully you got that right. Okay, so basically what we have now is the integral of, well, a is 7, so we're going to have 7 1 over x plus 2 dx. And then we'll have b, which is -11. So it'll be -11 times the integral of 1 over x plus 2 squared dx. And we did this earlier. The first one, obviously, is going to be 7 times the natural log of the absolute value of x plus 2. And the second one is equal to -1 over x plus 2. Again, I'm using what we did the other day. You let u equal x plus 2, so du is dx. So we end up with 1 over u squared du, and that's u to the minus 2 power, so you add 1 to the exponent, you get u to the minus 1, divide by the new exponent, which is -1, so that's where you get the negative sign from inside the parenthesis, and 1 over u is the integral of 1 over u squared, so you get, you just take 1 over x plus 2. So I guess the final answer, cleaning it up a little bit, is going to be 7 times the natural log of the absolute value of x plus 2 plus 11 divided by x plus 2 plus c. Okay, next problem. So the next one is a distinct linear and quadratic expression. So remember what we do there, we just did it a while ago, is you're going to make a be the coefficient associated with x minus 2, and bx plus c the numerator of the quadratic part. So I don't have an integral there, but I do want you to, we are going to integrate it. So that's going to be a divided by x minus 2 plus bx plus c divided by x squared plus 5. And really, if you go back to your notes at the beginning of class, the only difference between that one and this one is that it's not a complete square, so you're going to have your answer is going to have square roots in it. You're going to end up with the square root of 5. Ultimately, when it comes to the arctangent part of the solution. As far as the natural log part, you won't have the square root of 5. But okay, so go ahead and cross multiply the numerators and the denominators. Set those equal to the numerators equal to each other. The coefficients, you'll end up with 3 equations in terms of a, b, and c. And we can use substitution here, so we can solve the first 2 equations for the appropriate variables and then substitute them into the third equation and make it in terms of one variable and then go back substitute. A, in this case, A is going to be equal to negative B. That always happens when you don't have an x squared in the numerator of the original expression. Yeah, my next thing is, so I was somewhat wrong about car rentals. You can rent it, you just have to pay more. So if you're on a business trip, that's okay because they're paying for it. The business or the question is how old. So when you put in what is the maximum age to, the top choices are to join the military, to join the Navy, to join the Army. Well, again, it says there's surcharges. If you're over 70, you can in the U.S., the maximum age for rental car is unheard of. But in Europe, my mother had to stop renting a car. I think when she was 80. Huh. Well, there is no. Huh. It says none. Wow. In the UK, you can rent a car as young as age 17. You just have to pay more. That's not right. Yeah, that's right. Okay, so let's see if everybody got what I got. So I got A was equal to 8/9. B was equal to negative 8/9. And C was equal to 2/9. So what I did is I solved this for A, this for C, plugged it into this equation, multiplied it out, combined like terms, move this to the other side, solve for B, negative 8/9, so therefore A is positive 8/9, and C was 2 plus 2 times negative 8/9. What I did here is I took 9 times 2, which is 18, so this is 18/9 minus 16/9, which is 2/9. So my original integral is going to end up being 8/9 times the integral of 1 over x minus 2 dx. So that's the A part. And then I have minus 8/9 times the integral of x divided by x squared plus 5 dx. So that's the B part. And then I have the C part, so I have plus 2/9 times the integral of 1 over x squared plus 5 dx. So my original integral could be broken up and made into 3 separate integrals. This one is going to be the natural log of the absolute value of x minus 2. This one will be the natural log of x squared plus 5 times 8/9 divided by 2 again, because you'd have that u substitution effect here. And this one would end up being the 1 over the square root of 5. So you take the square root of 5 here, times the arctangent of x divided by the square root of 5 times 2/9. So let me go ahead and write that all out. So the first integral will be 8/9, the natural log of the absolute value of x minus 2 minus 8/18 times the natural log of the absolute value of x squared plus 5 plus 2/9 times 1 over the square root of 5 times the arctangent of x divided by the square root of 5.